Welcome everybody to today's lesson about solving equations. Our goal when solving equations is to find a value for the variable that makes the equation true. We will use inverse operations to isolate the variable, or in other words, get the variable by itself. Sometimes intermediate steps are necessary. Sometimes we'll need to distribute, combine like terms, etc. in order to get to our solution. First, when solving equations, we need to undo addition and subtraction. Then we can move on to multiplication and division. Before we get into our first example, let's talk a little bit about inverse operations. Inverse operations are essentially the opposite. So when you think about addition, the opposite of adding would be subtracting. The opposite of multiplication is division. This also works backwards. So the opposite of subtraction is addition. The opposite of division is multiplication. This is important to remember when solving equations because when we're trying to undo an operation, we'll use the inverse. So, when looking at example number 1, we first want to undo that addition. So we'll use its inverse, subtraction. We're going to subtract 7 from both sides. It is critical that we remember that what you do to one side, you have to do to the other side. Remember, this is an equation, meaning both sides are equal. We need to keep it that way by subtracting 7 from both sides. Now we complete my subtraction. I do 13 minus 7 and get 6. 7 minus 7 is 0, so it goes away, and I'm left with 3x. I will then undo this multiplication. To do so, I divide both sides by 3. 3 divided by 3 is 1, so x is left by itself, and 6 divided by 3 is 2. So my final answer is x equals 2. Let's look at another example. In example number 2, we're going to use a method called multiplying by the reciprocal. But first, we need to undo this addition. So I'm going to subtract 14 from both sides. Remember, have to keep that equation balanced on both sides. I complete my subtraction and do 8 minus 14, and I get negative 6. 14 minus 14 is 0, and I'm left with 3/4 a. Now at this point, I could do two things. I could divide by 3/4, or I could multiply by the reciprocal, which gives me the exact same result. So we're going to multiply by the reciprocal, and reciprocal, you'll remember, is when we flip that fraction upside down. So I'm going to multiply both sides by 4/3. When I do so, I get 4 times 3 up top and 3 times 4 on the bottom. That's going to give me 1. So a is by itself. And on the other side, remember when I multiply fractions, I multiply straight across. Negative 6 times 4 is negative 24. 1 times 3 is 3. So negative 24 divided by 3 is negative 8. Don't mind that, that's just the bell. Question number 3. We want to combine some like terms first. When we combine like terms, we're looking for terms that have the same variable with the same exponent. In this case, 2y and negative 8y have the same variable and neither one have an exponent. So it's going to be okay to combine these terms. I've got 2y and a negative 8y. Don't forget to include that negative side in front of it. 2y and negative 8y become negative 6y. 29 stays around, equals 5. I need to undo my addition, so I'll subtract 29 from both sides. When I complete that subtraction, I'm left with negative 24 equals negative 6y. Alright, I'll rewrite my work up here. To undo my multiplication, I need to divide both sides by -6. In doing so, my -6's cancel, and I have -24 divided by -6. And remember, when I have negative on top and bottom, they cancel out. So I'm left with just 4. Awesome. One more example, then you're going to try some. In example number 4, we are using the distributive property. This happens when I have a number being multiplied by a quantity. The distributive property tells me I need to multiply everything inside the parentheses by the number outside. So in this situation, I'm going to multiply 3 times x and 3 times -9. The result will be 3x minus 27. That still remains equal to 30. Now, don't worry about working with just one side of the equation because I didn't change the value on this side of the equation. I just simplified, so no values were changed. Now, I can get into my solving. I need to undo this subtraction by adding 27 to both sides. I complete my addition and I get 57 is equal to 3x. I'll divide both sides by 3 and x equals 19. Very good. Now it's your turn. I've got 4 problems that you're going to try OYO, or on your own. Please pause the video, try these 4 questions, and then check your answers. Alright, for question number 1, you should have subtracted 13 from both sides. You're left with 4t equals -8. You will divide both sides by 4 and be left with t equals -2. Question number 2, start by adding 5 to both sides. You'll be left with 2/3 x equals 10. You'll have to multiply both sides by the reciprocal, 3/2. You'll be left with x equals 15. Question number 3, got to combine some like terms. So x and 2x becomes 3x minus 4 equals 14. You'll be adding 4 to both sides to undo that subtraction. So 3x equals 18. Divide both sides by 3, and x equals 6. Last, we'll have to use that distributive property. So I do 4 times y and get 4y. 4 times 1, and I get 4. And this is all equal to -8. I subtract 4 from both sides to undo my addition first. 4y then equals -12. Divide both sides by 4, and y equals -3. There you have it. I hope you've learned a little something today about solving equations, and stay tuned for the next edition from Garris Math.